Welcome to this episode of Night Sky News for November 2021 with me, astrophysicist Dr. Becky Smethurst. This is a show where we chat about what you should look out for in the night sky in the next few weeks, and we chat about what's been happening in space news in the past few weeks. If you want to skip ahead to any specific news story, there's chapter markers down here, and if I mention any scientific papers, they'll all be linked in the video description down below as well. But without any further ado, let's kick things off and start by looking up. Alright, early tomorrow morning, Friday the 19th of November, the full moon will be turning orange. This is what's known as a partial lunar eclipse, when the moon essentially passes through Earth's sunset shadow. Earth's shadow isn't solid, it's got this very thick atmosphere around it. So sunlight actually passes through the atmosphere and refracts, it changes direction. And red light refracts more than blue light, and so it changes direction enough that all the red light ends up shining on the moon's surface and the moon appears reddish orange to us. The best view of this is going to be in the Americas because the moon starts to enter the Earth's shadow at about 6 a.m. GMT and will reach maximum eclipse, or the maximum orange it will get, at 9 a.m. GMT, right? At which point the sun will have risen for those of us in Europe. But those of you who are early risers on the east coast of the Americas and night owls on the west coast, you are actually going to get a great view. The best place to spot this is going to be Hawaii and the other Pacific islands because it will reach maximum eclipse as the moon is rising, right? And that always looks spectacular because then you've got the perspective and the moon will look bigger. You'll also be able to catch it if you're on the east coast of Asia and Oceania and Australia, because then the eclipse will just sort of be finishing about when the moon is rising for you on Friday evening. As I said, a lunar eclipse on a rising or a setting moon is always incredible because you get that perspective. So if you manage to snap a picture, send them my way over on social media. Now, lunar eclipses don't come alone because if the alignment's right for a lunar eclipse, it's also right for a solar eclipse as well. And that's exactly what is happening on the 4th of December. But unfortunately, it's only going to be visible from Antarctica and partially from South Africa. I'm sure there are some very lucky people out there that have booked onto Antarctic eclipse cruises and know that I am very jealous because how incredible would that be? But for the rest of us, speaking of moons and eclipses, if you have a telescope, then Sunday the 28th of November is going to be a great time to break that out because Io will be transiting across Jupiter when the Great Red Spot will also be visible as well. So you'll be able to see this dark spot, this shadow of Io on Jupiter with a decent telescope and magnification. This won't be visible for those of us in the UK and Europe or anywhere really east of here because Jupiter will have set by the time this starts at around about 11:20 p.m. GMT. Again, the best place to see this is gonna be the east coast of the Americas because you'll be able to see the full eclipse from Io appearing on one side and disappearing off the face of Jupiter on the other side again. It's gonna start around 6:20 p.m. Eastern time and last for about 2 hours, which means that those of you on the west coast will just about catch the end of it. As we get more and more into December, Mars is going to be rising higher and higher every morning in the morning sky. It had disappeared from our skies for a while as it went behind the sun from our perspective here on Earth, and all of the probes and satellites around Mars went into sort of radio silence for about 2 weeks. But it is now moving further away from the sun from our perspective as we see it, right? It's sort of projected on the sky. It's not actually getting further away from the sun, right? It's a very stable orbit, but as we see them in the sky, it's getting further away, which means we have longer to spot it in the morning before the sun rises behind them. Now, a good day to look for this, if you're not sure what you're looking for especially, is the morning of Thursday the 2nd and Friday the 3rd of December, when the crescent moon, aka a toenail moon, as I like to call it, some people have started thinking that's an official name. It is not. When the crescent moon will actually be very nearby in the east towards the sunrise. I was about to say it's easier to spot if you're in the Northern Hemisphere, but it's not that it's easy necessarily, it's that it's more convenient for those of us in the Northern Hemisphere that are currently in the depths of autumn and winter because the sun isn't rising until late morning, right? We can get up and start our day as normal, maybe, crack the curtains at 7 a.m. and try and spot this looking east towards the dawn. Whereas if you're, say, in Sydney in Australia and you want to spot this, well, it's going to be a 4 a.m. get up for you. Then finally, in the middle of December, we have the Geminids meteor shower, which is one of the best of the year and visible worldwide. Normally this shower has around about 120 meteors or shooting stars per hour, which is like 2 a minute, right? It's a lot, from the brightest to the faintest, streaking across the sky, blink and you'll miss it. Now the shower lasts a few weeks or so, but it'll peak with the most meteors an hour on the night of Monday the 13th going into the morning of Tuesday the 14th of December, which annoyingly is when the moon will be about 3/4 full and therefore very bright, washing out a lot of the faintest meteors, meaning that the best time to watch for them is actually about 3 a.m. onwards when the moon has set. Not exactly a convenient time during a work week like on a Tuesday morning, so you could also look for these on the weekend of the 11th and 12th as well, perhaps if you have a clear night then too. It's not necessarily the peak, it might not be 120 meteors an hour, it'll be slightly less, but you should still see them. So to watch, all you need to do, wrap up warm first of all, and grab something comfy that you can sit on and look up towards the sky. You should essentially look anywhere but directly at the constellation of Gemini, as that's where all the meteors will be streaking away from. Now in the northern hemisphere, that means looking north-ish, and in the southern hemisphere, looking south-ish. If you're on the equator, it will be right above your head. So essentially the worst thing you could do is maybe lie on a sunbed and look directly up. As long as you look anywhere else in the sky, you should spot some meteors, but perhaps get a few of you like all sat back to back maybe to try and spot them all. As always, if you snap any pics like this one, for example, perhaps you set up your camera to take like a 10-second exposure every minute or so and just see if you get lucky and capture a meteor streaking across it in that image, then send them my way over on social media and I will share my favorites with everybody because, I love to see them. All right, that's enough for looking up at the night sky. Let's come back down to Earth and chat about what's been happening in space news in the past month. All right, let's start with JWST, the James Webb Space Telescope. We are fast approaching its launch date of December 18th. The astronomy community is practically holding its breath and keeping all of its fingers crossed. We're very, very excited. Now, last month it was actually shipped across the ocean from the US through the Panama Canal to French Guiana. And now that it's there, it has been unpacked or unboxed, if you will. The European Space Agency ESA literally released an unboxing video to end all unboxing videos, taking the telescope out of the container it was shipped in and bringing it out into the clean room where it was then pivoted so that it was upright in the position it would be in when put into the Ariane 5 rocket it will be launched on in the next few weeks. I still haven't decided if I want to watch the launch of JWST yet. I'm really nervous. And my research doesn't even depend on it succeeding. So I can't imagine how those who are a bit more closely involved are feeling right now. I think it's either going to be one of those things where it's like, I can't watch or I can't look away. And I still don't know which one it's going to be yet. To distract us from the launch of JWST, though, one of the biggest things that happened in the astrophysics and astronomy research community this month was the release of the decadal survey known as Astro 2020. Essentially a big report on what the science goals are for the next decade in the field and what technologies, tools, and telescopes will be needed to achieve those goals. It's written by everyone in the community, essentially, right? With experts, liaising with all the people in their field, whether that's, solar system, exoplanet, stars, galaxy, cosmology, or if it's even the people who build the instruments that we put on telescopes, right? The detectors themselves, right? They all come together, write their report, and then there's a central panel that brings everything together and then makes big recommendations for the future. It's a really big deal. It creates a lot of buzz because it really does set the tone for what people in the community think we should be focusing on in the next decade or two. So it's not exactly a short paper. It's 616 pages long. I will link it in the video description down below. You can read it online for free if you want. But I can also pick out some recommendations now to save you from the torture of 616 pages. The first recommendation they make is that we need a new observatory that's focused on habitable exoplanets. So something that can see in the range of infrared, optical, UV, pick out the things like biosignatures that suggest that life might be present, that you can detect in the atmospheres of exoplanets. And they say that the community needs to start planning for that now for launch in the 2040s. The next recommendation they make is that we need a next generation cosmic microwave background observatory, either in Antarctica or in Chile, to search for signatures of gravitational waves caused by inflation in the early universe. And specifically, people are still focused on detecting what are called these B modes, the polarization signatures of magnetic fields that are imprinted on the cosmic microwave background that the BICEP telescope claimed to have detected back in 2014. This is a telescope in Antarctica, but then it turned out that what they detected was just the effects of dust. So I think people are still hurting after that. We need a new telescope that's going to be able to do this and actually be able to detect it. So something that's a lot more sensitive than BICEP was. They also point out that all of the science and technological recommendations that they make for the future are not going to be possible without the actual people that work in the astronomy community. And they make a lot of recommendations on how they should best be supported to make the astronomy community and astronomy education more equitable for all, right? To ensure a diverse workforce. They actually state the astronomy and astrophysics enterprise can be at its most innovative only when it maximizes and fully utilizes the diversity of its human talent. Hehe. Alright, from the serious to the frankly wonderful and slightly bizarre story of Heinz, as in Heinz tomato ketchup, making ketchup out of tomatoes that have been grown in Martian analog soil recreated in a lab in Florida. I guess if Mark Watney had had that idea, then this would never have happened.
It's been 7 days since I ran out of ketchup.
As much as this sounds just like a clever PR stunt, right, there is actually some really useful science behind it, and it comes from an astrobiology team led by Professor Andrew Palmer at Florida Tech, who worked in a greenhouse to try and replicate the conditions humans might face in the future, perhaps farming on Mars. So the soil that they used to grow the tomatoes was shipped in not from Mars, but from the Mojave Desert in the Sierra Mountains, because it mimics the characteristics of Martian soil quite well. They didn't use any sunlight to grow the tomatoes, but instead just really bright LED lights instead, because they thought it was only what would be available to humans, you know, inside any sort of like habitat that you could build on Mars. And then also there was really strict sort of like temperature control as well. And of the, you know, entire list of species of tomatoes that you could have grown, you know, they picked 4 in the first place that they thought could actually grow in these conditions. And they did an initial test and found that 2 of them did. So then they went on with this much larger experiment with about 450 tomato plants, which not only grew, but, you know, were good enough to apparently make into ketchup with Heinz. There was a lot of challenges along the way, which meant that they didn't get as big of a harvest of tomatoes as they hoped. Some of them died, but all of that will be lessons learned, you know, and written up and saved, and, you know, sort of the collective human knowledge in case one day any one of us finds ourselves, you know, trying to grow crops in the Martian soil, Mark Watney style. Alright, the next news I want to talk about is these 2 papers that were published this month. One led by Sophia Shake and one led by Shane Smith, about a strange radio signal that was detected coming from the nearest star to the sun, Proxima Centauri, which is about 4 light years away. It takes light 4 years to get from that star to us. It was spotted as part of SETI's Breakthrough Listen project at the Parkes Radio Telescope in New South Wales in Australia way back in 2019. And people got pretty excited about this because there are 2 known planets around Proxima Centauri, and this radio signal was a little bit weird, and people got excited. Could it be what's called a techno-signature, an engineered radio signal that is clearly not from natural occurring phenomenon, but is engineered by a civilization that is communicating using radio signals in the same way that we are? It was basically the exact plot of the film Contact, right, with Jodie Foster, except they didn't announce it to the world the very next day because they knew that the signal, which was dubbed BLC-1, needed analysing first. They needed to go through every single possible other explanation first before they could declare that it was a techno-signature from another alien civilization, right? You've got to be really sure before you announce that. Of course, the news still leaked, with The Guardian newspaper leaking the story last December 2020. Now, there was a lot of people on the internet talking about this at the time. However, in my Night Sky News for December 2020, I didn't talk about it because I was waiting for the peer-reviewed paper, right? When they'd finished doing all the analysis and it's been checked by someone else in the field to say, yes, that makes sense, or no, this science isn't right. That's what I was waiting for. And that's what's come out this month with these two papers. And unfortunately, they've concluded that this signal wasn't real. It was something known as radio interference, or RFI. Essentially, that's something on Earth that's producing a spurious signal at the same frequency of the thing that you're trying to observe. And that could be generated by anything from a mobile phone to a satellite passing overhead. Yeah, it's not just optical astronomy that the 50,000 plus Starlink satellites will affect. It'll probably affect radio astronomy a lot more. This RFI, though, was a bit rarer than a satellite or a spurious mobile phone signal, which is why the team didn't really recognize it for what it was and why the signal was flagged as something of interest in the first place. But eventually, after going through all of the options and analyzing the data, the team figured out that what they detected was a signal from something called a clock oscillator, which is essentially a crystal that vibrates and produces a signal at a constant frequency so that it can be used in a clock. So they're used in like quartz watches, for example. So if you have a quartz watch, don't go anywhere near a radio telescope because the astronomers will not thank you. And what the team eventually ended up finding was 60 more of these signals that looked pretty much the same as the one that they thought was coming from Proxima Centauri. And the majority of those 60 extra signals that they found are what's called off-source signals. So they're signals that don't appear to be coming from any specific object in the sky. And that was sort of a bit of a giveaway that what they found wasn't anything real from space. It was just radio interference and definitely not alien in origin. So Jodie Foster's just going to have to wait that little bit longer for the trip through the wormhole. But you know, if you want another strange, unexplained radio signal to focus your energies on, then there's always J173608.2-321635, which is coming from roughly the center of our galaxy, the Milky Way. Now, it was discovered by the ASCAP radio telescope in January 2020 and reobserved throughout the year. Now, the strangest thing about this radio signal, this radio light that's been detected, is that it is polarized. So we talk about polarized light, we're talking about the alignment of the light. So as the light wave comes towards you, it can come towards you like that, or like this, right, in this direction. So when we're talking about polarized light, all of the light waves are aligned so they come at you in the exact same way. And that's not that weird. You know, light can be aligned by magnetic fields, for example. We know there's high magnetic fields towards the galactic center. But this signal is circularly polarized, which means that the alignment is rotating at a constant rate. So that's weird, plus the fact that it varies in brightness by about a factor of 100, completely random. That's completely unpredictable. Then it will also just disappear and reappear completely at random as well, and we have no idea and can't call when that's going to happen. Now, random behavior once again suggests that it's not aliens, and instead is in fact a very natural but very chaotic process that's occurring. So the paper describing the detection of this signal by Wang and collaborators considers a lot of options to explain it. A pulsar, a magnetar, even something called a galactic center radio transient. They considered all of those, but none of those explanations fit the data that could explain the signal that they'd observed. So this signal is still unexplained. Unexplained, but not aliens. And finally, a possible first for this month, and a very big first at that too. The first planet outside of our galaxy, the Milky Way. It's in Messier 51, the Whirlpool Galaxy, one of my personal favorites because, well, just look at it. So some context as to why this is such a big deal. We've found exoplanets before in our own Milky Way galaxy, 4,800 of them to be exact. There's probably billions more, but we found them by observing individual stars, and that's something you can only do in the Milky Way. By the time you get to other galaxies, for example, like in Andromeda, 2.5 million light years away, they all blend together. Clusters of stars look like individual stars, but you're actually seeing a very bright cluster, but you can't see individual stars. For example, to see if their brightness dips periodically to show that there is a planet they're passing in front of. Or, for example, to take a direct image of a planet by blocking the light from the star that it's orbiting around and detecting the reflected light off the planet. The only individual objects that we can see in other galaxies, millions, billions of light years away, are those that give off really high energy light like X-rays. Things like neutron stars and black holes. That if they're orbiting normal stars, start stealing material from them and they accelerate that material to huge speeds and temperatures of close to 1,000,000 degrees so that it glows in X-rays. We find these across our own galaxy, but we can also spot them in other galaxies too because they're so bright. So bright that if, for example, they disappeared and reappeared again because something passed in front of it, then you would notice it, at least if you were paying attention. Now, DiStefano and collaborators had this idea and they searched the X-ray data archives and managed to actually spot a dip in the brightness to pretty much almost zero in the data that they had way back from September 2012 for an X-ray binary in Messier 51. Now, once again, you have to be very careful here. Like, what's that famous saying in medicine? If you hear hoofbeats, think horses, not zebras, right? The astronomer's equivalent of that, our horses, is dust, right? So like, is Betelgeuse gonna go supernova because it's dimming? Oh wait, no, it was just dust. Is the Water First Star like an alien civilization that's perhaps built this incredible megastructure around it? Oh no, it's just dust. Oh, did Bicep 2 detect BMO polarization in the cosmic microwave background? Oh no, it's just dust. So the team had to triple, quadruple check that it wasn't dust first. But in this case, the dust explanation doesn't actually fit the data because all the wavelengths of X-rays were affected exactly the same. Dust affects different wavelengths differently, so you'd expect a different response, so sort of across the X-ray spectrum, but actually it was all the same, suggesting that it was something solid that had blocked out the light. Plus the dip in the data, it was very symmetrical, suggesting something very uniform in shape, like something circular, like a planet or another star of a very low luminosity. If it was a star, that would make it a tertiary system, right? Because you've got the neutron star or the black hole orbiting the star that it's pulling material off, and then if you had another star, it would be orbiting around those two. That would make it what's called a tertiary system, which aren't that rare, so that wouldn't be that unbelievable. And so obviously if you're going to try and figure out, well, is it another star or is it a planet that's orbiting this strange neutron star, black hole, another star binary system, you need to work out what size the thing is that's passed in front of this X-ray source and made it dip in X-ray brightness. So the shape of the dip actually depends on a few things. It depends on how big the object is that's moved in front of it, how far away that object is from the X-ray source, and also the speed of the object as well. And if you model all of those different things, you can see how the shape of that curve would change. And so what you can then do is find the model that best fits the data that you have, which is exactly what DiStefano and collaborators did, and found the most likely model to explain what they'd seen. And they found that it wasn't a star, it was instead a planet about the size of Saturn. Which is really cool that the model suggests that that's what they found here, but it doesn't exactly confirm that that is what it is. You really need a bit more evidence. Now, the only evidence that they could actually probably get in this case is observing another transit, and then another one and another one at regular intervals that you could predict to show you that there was something that was periodically passing in front of it and would be a planet. Of course, you don't know when that could be. It could be a planet that's orbiting at such a great distance that it could take hundreds of years for it to orbit its star. Or, like Saturn, it could take about 12 years, in which case we're due another one very soon. But again, you just don't know when to look to catch that transit that doesn't exactly last for very long either. But this does open the possibility of finding more of these possible candidate planets orbiting around these X-ray binaries, these greedy neutron stars or black holes outside of our own galaxy. And, this could just open the floodgates, to finding more of these, not exoplanets, but extra-galactic planets, I guess. Ego planets. I don't know what we're going to call them. We'll probably come up with some ridiculously contrived name for them. What such planets would be like, though, is another question entirely, right? Because not only have they survived the supernova that produced the neutron star and the black hole, but they're now being irradiated by such high energy X-ray radiation that can be seen 23 million light years away that I don't think they're necessarily going to be habitable in anybody's book, but probably have a lot to teach us about the death of planetary systems around dying stars. Alright, on that cheerful note, that's it for Night Sky News for this month. Last weekend I watched the new Tom Hanks film, Finch, which is like a post-apocalyptic thing after a solar flare, and we have a lot to chat about that film. So next week's video is going to be an astrophysicist reacts to Finch, so look out for that. In the meantime though, if you happen to do any stargazing and you capture any night sky pics, send them my way over on social media. I always love to see them. But for now, happy stargazing, everyone. Before we get to the bloopers, I just want to say a big thank you to this week's video sponsor, CuriosityStream. CuriosityStream is a subscription streaming service with thousands of documentaries from the world's best filmmakers. Now let's face it, you wouldn't be here on my channel if you weren't curious about the world around you. And CuriosityStream is essentially the streaming service for people just like you who want to learn more. Plus, it doesn't cost the earth at just $20 a year. Now you can bet there is an entire space section for us space lovers on CuriosityStream. I particularly love this documentary on how the team at the Hubble Space Telescope take and process their images to give us those beautiful shots that we all grew up seeing. But whatever you're interested in, you can find on CuriosityStream, whether that's science, nature, history, music, sports, and even crossover genre documentaries. Like this one I enjoyed on the moon's influence on coral spawning in the Great Barrier Reef. It is available worldwide to everybody. So if you're interested, head to curiositystream.com/Dr. Becky or use code Dr. Becky, that's DRBECKY, when you sign up to get 25% off a yearly subscription. That's just $14.99 for the year or $1.25 per month, which is an absolute bargain in my opinion for all of that knowledge and entertainment. So thank you so much to CuriosityStream for sponsoring this video and supporting this channel. And now, roll those bloopers. The best place to spot this is going to be Hawaii and the Pacific Islands. As much as this sounds like a bit of a clever PR stunt, there is actually some really useful science behind it. So a team led by Andrew Palmer. Now this light specifically is what's called circular, oh my god, it's very late on a Friday afternoon. Oh, I need a glass of wine. Circularly. And if it's polarized, it means that the orientations are all lined up. This light is what's called circularly polarized. Is that right? Circularly. Yeah. Why did I even pause? I was right. Circularly polarized. Circularly polarized. Dust was there. I remember it all too well. Yeah. Maybe we got lost in translation. Maybe it was just too much dust.